All right, so now we're on our second trend, ionization energy. So looking at our standard, I can explain, we're on the second one, I can explain the trend for ionization energy using the periodic table, use it to compare the atomic radius of elements. Yeah. So, ionization energy, what is it? So, remember, an ion is an electron that has, or is an atom that has lost or gained electrons. So, ionization energy is specific to the amount of energy it takes to remove an electron from an element, i.e. turn it into an ion. So, like hydrogen has 1 electron. So this number right here, this is hydrogen. This is the amount of energy it takes to take that 1 electron away from hydrogen. Okay. So let's talk about the patterns that we see here. So here does this mean? The higher the ionization energy for an atom, the harder it is to remove an electron from an atom. And the lower the ionization energy, the easier it is to remove an electron from that atom. So when you look at this table, what you start to notice right away, or this graph, is there's 2 that we've labeled. There's all of these right here, which I hope you look at them and you go like, oh, those are all noble gases. Okay, and then you see these other ones we've labeled down here, and hopefully you go, oh, those are alkaline earth metals, or alkali metals, which I can't spell. Okay, so what else is it? This is the very first column on the periodic table, and this is the very last column on the periodic table. So keep that in mind. And then also think like, all right, so noble gases have the most, and they're stable. We talked a lot about they're stable. So if something's stable, it really does not want to become unstable. Atoms are all about being stable. So the noble gases, it takes a lot of energy to strip away an electron from them because they are so stable. While these guys, they only have 1 electron. Remember, if you think about our noble gas configuration, lithium would be He2S1, sodium would be Ne3S1. All these guys, on and on, this 4S1, 5S1, 6S1, all these guys, they only have 1 electron to be like a noble gas. Like if they got rid of this electron right here, they would actually be like a noble gas, which means they don't actually hold on to their electrons very well. They're totally fine ditching those electrons, which is why the energy level to take them is so low. So let's talk about the trends that we're seeing here. I hope that makes sense. Why? It's all about making making ions. So why is it easier to remove electrons from atoms further down the group? So what's our trend? When we look at our periodic table, what happens to the energy? The energy gets lower and lower. So as we're going, this is going down the periodic table. This is going from top to bottom, right? Because helium is the top. This is also going from top to bottom. What do we see? The energy is going down. Why, when you're dealing with your periodic table, why is it as we go down the table, it takes less energy? Well, that's because these are bigger and bigger and bigger electrons. So the electrons are further and further away. Imagine if you have one person who's wearing okay, I'm going to keep it with females in general. You have one person wearing a bikini and another person wearing 7 layers of coats, okay? So the first person, guy or girl, maybe they're choosing to wear a bikini top, cool, that's all them, yay for you, make your choices. Okay, they put their cell phone in their bikini strap. So in the strap up near the top, right? The other person wearing 7 layers of coats puts their phone in the outermost pocket of the outermost coat. Who is going to notice getting their phone stolen first? Right? The person whose phone is in there next to the held on by the strap, in there tucked into the bikini strap, they're going to notice if somebody reaches up and grabs their phone. It's going to take a lot of energy, much like helium, who is one of the smallest atoms on the periodic table, is really going to notice if somebody tries to take their electrons. It takes a lot more energy. But poor radon over here, radon's a big guy, and he's got a lot of coats on. So this is the person who's got 7 layers of coats on. How hard is it going to be to pick their pocket and take their phone? it's going to be fairly easy because that phone is really far away. Okay, they're not going to notice as much. So that's why as you go down the periodic table, the ionization energy also decreases. Okay. Now, what about as you go from left to right? Okay. Well, let's look at our table. As you're going across the period. So this graph right here, where's across the period? Well, lithium is one end of the period, neon is the other. So this is actually going across our period, right? This is going from left to right. Okay. What happens to the ionization energy? Okay. As we go from left to right, as we go across the period, the ionization energy goes up. So why? Why is it harder? Well, that's what I was talking about earlier. Remember, this comes back to that atomic radius. Okay? Lithium has a much bigger atomic radius than neon because neon has got the best ratio of protons to electrons in the second shell. So neon is much, much smaller. Okay? So this would be like the idea, yeah, like they're both wearing coats, but this guy's got a big, thick down coat, and this one's got like a thin, light windbreaker. Okay? So there's still layers, but his stuff on the outside of lithium is further away than stuff on neon. So it's still easier to take. It's basically comes down to it's easier to take an electron from a larger atom. Okay? So as you go down the periodic table, the atoms get bigger, so it's easier to take their electrons. And then the largest elements are over here on the left-hand side. These are the largest, and they get smaller as you go from left to right. So it's easier to take from the guys on the left-hand side than it is on the right. And the amount of being able to take them, the amount of energy it takes to take them, that's the ionization energy. We will, at some point, you'll see some practice though. So this one right here. This graph is only for taking the first electron. Ionization energy changes depending on how many electrons. Like lithium only wants to get rid of one, then it's going to be just like helium. After you've taken one electron from a lithium, it's really easy to take one electron. It's really hard to take two. And you'll see more about that. So this is just ionization energy for the first electron.